Exercise 3, coordinate geometry, gradient formula. So there's 5 questions for you to have a go at here. First one is find the gradient between the points -4, -2 and 3, 1. Number 2, find the gradient between the points -1, 8 and 2, -4. Harder one, find the gradient between the points CT, C over T and CR, C over R. Part 4, find the angle the line during 1, 3 and 3, 1 makes the positive direction of the x-axis. I'll just move this up a little bit so you can see it better. Find the acute angle between the two lines that have gradients √3 and 1 over √3. Alright, so just pause the video, right, and have a go at those 5 questions. The answers will follow. Right, now here are the answers for the first one. Let's say M is equal to 3/7. This one here, the gradient is equal to here -4, negative gradient. This one here, the harder one. Did you get this one? -1 over RT. The angle here was 135 degrees. And the angle here was 30 degrees. Right, here are the solutions to the exercises. So write down the formula. M equals y2 minus y1 over x2 minus x1. Alright, there's my x1, y1, x2, y2. So that will be 1 take away -2 over 3 take away -4. And that's going to give me 3 over 7. Okay, the next one. Writing the formula down again. Because each time you write down this formula, it helps you remember it. Okay, now we're putting in the x1, y1, x2, y2. This just prevents any sort of reading error by popping that down. Okay, and that's going to give me -4 minus 8 over 2 take away -1. That's going to give me -12 over 3, which gives -4. Okay, now for the harder algebraic one. So we write down this M equals y2 minus y1 over x2 minus x1, x1, y1, x2, y2. Putting them in. Now that becomes C over R minus C over T over CR minus CT. Okay, now this becomes CT minus CR all over RT, and this becomes CR minus CT. Now taking out the common factor of C here, we get C outside of T minus R over RT. Now this will be times 1 over C outside of R minus T. You can see they're almost the same. We'll just cancel those C's. But if we change this around, we'll take the minus sign at the front, then they'll cancel. So that could be written as T minus R over RT times minus T minus R. And of course now they'll cancel out because they're the same. And you're going to get simply the result minus 1 over RT. Alright, now in this one here, I'm going to plot the points. You don't have to, but it just makes it a little bit easy to see if you've got the correct gradient or not. So now we're going to have 1, 3, 1, 3 up here, and 3, negative, 3, 1, 3, 1 here. And you can see, I think, that you're going to have a negative gradient. It's a nice little check step, that one. Okay, formula m equals y2 minus y1 over x2 minus x1. Okay, so I'm going to start off with this one. So 1, take away 3, over 3, take away 1. Of course, that's going to give me here 1 take away 3 is negative 2. That's going to give me 2, so that's negative 1. So our angle, we can see that we're after the obtuse angle here. So m equals the tan of theta. So tan of theta equals negative 1. On our calculator we get the negative 45 degrees. But we know we're after this one. So that angle there is 135 degrees. Is the angle this line makes with the positive direction of the x-axis. Okay, last question. Now we'll just draw these gradients. Notice they're both positive this time. So we'll have a fairly steep one here. Going up like that. It's m1 equals root 3. And a shallower one going this way. m2 equals 1 over root 3. And we want to find this acute angle in here. We want that little one in there. And we're going to find this angle here. A different colour. Want that one there. And we want that one there. Alright. So we'll call this one theta. This one's our alpha. This one's our beta. Now the tan of alpha is equal to 1 on root 3. And then when you work that out in your calculator, you get alpha is equal to 30 degrees, or if you probably should know that. And this one here, beta, is equal to, that's our 60 degrees again. Now, so these two added together, so theta plus 30 degrees must be equal to the external angle, which is 60 degrees. So theta equals 30 degrees as our angle between the two lines.